Rise and shine, porcupines. It's Algebra with Al time. I'm your host, Al Rosetti. So we're looking at Chapter 5, Unit 7, Roots and Zeros. So after watching this video, students will be able to determine the types and number of roots. So the concept is roots and zeros. The skill is being able to determine them. Okay? So what do you say we get started? Here we go. So these first four problems that we're showing, you're going to solve these using all the inverse techniques that we have. They're basic equations, and you're going to come up with a solid answer. So those are zeros. Whatever values make these equations true, those are the zeros. So these first four you're going to solve. You're going to have a concrete answer. You're going to know that's the zero. So looking at number one, we got x equals negative 12 over 5. That is a solution. It is a real number. So you have one real solution. We know it's a linear equation, so you're going to have one real solution. All right, let's take a look at number two. Now we should know by looking at the exponent how many solutions we will have. That's what it tells us. So x squared, we're going to have two solutions, right? So we're going to solve this, and what are we going to do? It doesn't factor, so we're going to have to either use the quadratic formula or maybe completing the square. I use completing the square. I like it. I think it's underrated. But so in the end, if I complete the square, remember, we're going to add it to both sides, and I got x squared minus 2 quantity squared equals negative 36. Now, since it equals negative 36, you know right now that these solutions are going to be imaginary, right? So we have x squared, the square root of negative 36 is 6i. Finish it off by adding 2 to both sides, and you have two imaginary roots. One is x equals 2 plus 6i, one is x equals 2 minus 6i. Those are two imaginary solutions, but we solved the equations to come up with them, okay? We're not going to be doing that in the future. We're not going to solve them that way. We're going to have to just figure out. So look at number 3. So how many solutions are we going to have? We're going to have 5, right? Because you got x to the 5th. How do we do this one? Well, we're going to take out GCF. We know that. Take out x cubed. And we're left with x squared, right? Plus 4x equals 0. Plus 4. Now we set them both equal to 0, right? You have x cubed equals 0, and then we have x squared plus 4 equals 0. Subtract the 4 to the other side, take the square root of both sides, and you get a 2i. So you have two imaginaries right there, right? The plus and minus represents two different solutions. So you got two imaginary, and then you have x cubed equals 0, so you got x equals 0. That's 3 real and 2 imaginary, okay? All right, so 3 real, 2 imaginary. All right, let's take a look at number 4. How many are we going to have? Well, we're going to have 4 solutions. Question is, are they going to be real or are they going to be imaginary? Well, you should know that problem was the difference of 2 squares, right? And you're going to use the pattern. Okay, here we go. Now I moved up to number 7 because this is where we really want to focus. These are the problems, those ones that we just did kind of lead us into this, okay? So now we're not going to be able to solve these to come up with our answers. We're going to have to use some deductive reasoning. We're going to have to use a few techniques, but we have a way out. We have Descartes' rule of signs, okay? So what Descartes' rule of signs says is look at the equation and count how many sign changes you have, all right? Now, from positive to negative to positive. So we have 2 sign changes, right? Now, that means we're going to have either 2 real solutions or subtract, always by an even number, let's subtract by 2 equals 0, so we can either have 2 real or no real, okay? You're always going to subtract by 2. If it ends up less than 0, then it doesn't count. All right, so right now we either have 2 positives or 2 zeros, right? So now let's take a look at, now to find whether the solutions will be negative or not, we're going to rewrite the equation and for every variable x, we're going to make it negative, okay? We're going to write 3 to the negative x in parentheses to the third power. We're going to write 4 to the negative x in parentheses, then the squared outside. Okay? That's how we're going to find out whether there are negative solutions or not. Okay? So, Descartes' rule says find the sign changes. Once again, once you do this, you have to evaluate and find the sign changes. Okay? And the number of negative solutions will be, right, either the number of sign changes or always subtracting by an even number, which would be 2, subtract by 2, and that'll tell you how many solutions there could be. Okay, so let's look at it. I rewrote it, I evaluated it, and I have negative to positive, 1 sign change. So that says there's either 1 negative solution, and then 1 minus 2 is less than 0, so you can't, there are no, for sure, there's 1 negative solution, we know that. And there's either 2 positive or no positive solutions. So now, you're going to take that information, you're going to see I'm going to draw a little chart, and we're going to use deductive reasoning to determine what the imaginary solutions are, okay? So, right now, what we have, let's review, okay? Right? So, we know the total amount of solutions for this problem are going to be 3 because it's x cubed. Okay? Now, we know there's either 2 positive or no positive. We know there's 1 negative solution for sure because 1 minus 2 is less than 0, right? So here's the chart that I've drawn. Okay, and we'll fill it in. So, the first thing, I draw a line down the center now, and I write positive on the left side. And 2 or 0, okay? Then negative. We know there's only 1, so both squares you will fill up with 1. And we're trying to figure out what the imaginary could be, right? So here's where the deductive reasoning comes in. You guys are sharp enough, you can handle this. So if there's a total of 3 solutions, we know that. And we fill in the graph. Now, since on the left side is a total of 3, there's either no imaginary solutions, or on the right side we can plug in 2 to get to 3. So there's either no imaginary or 2 imaginary. For sure there's 1 negative, there's either 2 positive or no positive. So that's what they're asking for in that question, all the possible solutions. All right? All right, so I want to do 8 because I want to go through this one more time, okay? And make sure I've explained it well to you. So the first thing we're going to do, right, to find the positive solutions, is we're going to count how many sign changes. Now, from positive to negative is 1, and then back to positive is 2 sign changes. That means there's either 2 positive solutions or subtract 2 from it, and it's the next even number is why it's 2. And in this case, so we're subtracting 2, that equals 0. So there could be no positive solution. So right now it's either 2 or 0. Now, rewrite it with each one of these x's as a negative, and then we're going to simplify it. And when I do that, negative x cubed is negative x cubed times 4 is negative 4x cubed. So you can see now, I've done all the simplifying. And once again, I have 1 sign change. So that means I either have that means I only have 1 negative solution because 1 minus 2 is less than 0, so we can't do that. So for sure there's 1 negative solution. And how do we find out how many imaginary possible? We're going to draw a little chart, and we're going to fill it out, and we're going to be able to see what the imaginary could be. Now this is just all possibles. This is not the exact solutions because we're not solving. So positive 2 or 0. Negative for sure 1. Imaginary, either what? 0 or 2. There you go. So that's all the possible solutions for this problem. So I want to make sure we understand on these set of problems, all we're going to do is to the best of our ability come up with all the possible solutions, and at some point we're going to have to do some deductive reasoning. Remember, Descartes' rule, count the sign changes to find the positive, change all the x's to negative x, simplify it, then count the sign changes to see how many negative solutions, and then use those totals to calculate the imaginary solutions, okay? So this is somewhat of a guesstimate. We don't know the exact ones, we know what's possible. So, I appreciate you being here today. That's all we have time for. Remember, math, math, math. Get out and do some math.